So let's understand next circuit. Here we have a DC current source. If you right click here, it has a value of 1 milliampere. We basically click the components and we can type here current or CUR. That's it. It comes here and we just then see OK. And Control R from the keyboard will help us to rotate it. Okay, so that's how we generated and we placed it here. We press the escape button on the keyboard to get away from it. So that's how we placed and selected this component. The two resistors we selected from this symbol here or from the component library we can also select them. They have values of 1k each. The label was added here. The port type is none. This is just a net with the label A. We have added the ground. So and the analysis that we want to perform can be selected from this symbol, that is spice directive. We click here and we can write .op, which is the spice directive, and place it here. So that's how we have placed it here. Again, I press escape button on the keyboard to get rid of it. In other way, we can click again here and we select comment and we can write any comment and then click OK. So this is just a comment of about your circuit. This is my circuit. This is basically a current source, DC current source, and two resistors in parallel. So if we want to analyze this circuit through this circuit simulator, we need to know some theoretical calculations. So for that, we can refer to this slide. We see that this DC current source has been added here, and across them the two resistor R1 and R2 with the value 1k each. So the total current that comes out I, that passes through the resistors, that current is called as IR1 and IR2. Sum of them is I. So let's calculate the values of IR1 and IR2. We simply apply the current division rule. Current division rule which says that we take the value of, want to calculate value of IR1, so we take the value of R2 divided by sum of the resistance multiplied by the total current. That comes out to be 0.5 milliampere. IR2 can be computed in a similar fashion, that comes out to be 0.5 milliampere. So you sum them and here we get the total current, which is 1 milliampere. So this is 1 milliampere actually, not 1 ampere. Okay, and if we are interested to calculate the voltage drop across these two resistors, that is VR1 and VR2, which are by Ohm's law simply the product of current into the resistance. So they comes out to be IR1 0.5 milliampere multiplied by the value of R1, which is 1k, it comes out to be 0.5 volt, and VR2 also comes out to be 0.5 volt. So you see that voltage VR1 and VR2 is nothing but the voltage that is developed across this network, which is V, which is equal to 0.5 volt, and the currents are 0.5 milliampere. Let us see and confirm it with the simulation. We click simulate and click the button run. We see here now the voltage VA, which is the voltage at the node A due to the current source, is 0.5 volt, which is nothing but the voltage across R1 and voltage across R2. Now the current coming from the source I1 is 1 milliampere as shown, and the current through both the resistors IR1 and IR2 are 0.5 milliampere, what we calculated right over here, 0.5 milliampere. So this is how we design a simple circuit with the DC current source and two resistors placed in parallel to it.